Hi, I'm Dr. Abel Nasser. I'm one of the instructors for BMED 3310, which is Biotransport. I'd like to welcome you to the course. You'll be hearing from the other instructor and a guest lecturer in the rest of this video. But I just want to go over a little bit about the course before I hand it off to them. The purpose of the course is to introduce you to the fundamentals of transport of various things: momentum, which is basically fluid mechanics, mass transfer, and heat transfer. And we're going to specifically apply them to biomedical engineering problems. What you're going to be able to do at the end of this course is you'll be able to formulate the differential equations for these physical situations. You're going to be able to apply conservation laws. You're going to distinguish between the different modes of heat transfer and mass transfer. You're going to be able to apply differential mass balances, not just at the macro scale, but also at the differential scale. And you're going to be able to explain how the different areas relate between heat, mass, and momentum transfer. Now, this course we have converted, of course, to remote learning format because of the craziness that's going on right now. This is not business as usual for any of us, but we've tried to design the course with predictable rhythms and considerable flexibility because we care that you're able to learn biotransport in ways that work well for you and to make sure that you are okay during this semester. So please take care of yourselves. Let us know if anything comes up that disrupts your learning, even if it's unrelated to the course. We can point you towards university resources for equipment, mental health, emergency funds, and so on. We're all humans first, and grades are far less important than your health or your family's health or safety. So with that in mind, I'm going to pass this on to our guest lecturer.
Hi, I'm Mel Schwa. I'm a postdoc, and my background is in electrical engineering and also in researching engineering education. In my role here, I'm not formally part of the teaching team. I'm not involved with grading. What I'm doing here is, so this course, we've been wanting to improve for a while, and so we're studying your experiences, which means that sometimes I'm going to show up and do observations, ask questions, collect your feedback, and all this is going to be used to figure out how the course can be made better. Sometimes I'm also going to help with lectures, and you may have noticed that the voice right now is not me. We have an interpreter speaking, but still, watch me as I sign, because I'm going to be providing visual information that's important. So, and right now I'm going to just explain two more topics. The first of these being communication, and the second being lectures. So first, communication. This is an online course, which means that we're relying heavily on Canvas. And so check that you have access. And everything is going to be in Canvas. So we've got homework and exams and slides and lectures, and all of this will be in Canvas. And also, for class discussions, especially if you have questions, we're going to use Piazza. So you'll see in Canvas when you log in, over on the left-hand bar, there's going to be a Piazza link that you can use. And so what this means is when questions come in and they're kind of repetitive, we don't need to answer all of them. What one person asked and posts, we can answer once and everyone can look at that and learn. So office hours are also a thing we're going to have, and you'll see in Canvas that we have a specific schedule for that. So second, lectures. On Mondays and on Wednesdays, we're going to be uploading lectures. And so these are pre-recorded, which means that you can watch them anytime you want. You can watch them again if you want. You can pause them. It's really up to you. So a typical lecture for an in-person class is going to be around an hour and 10 minutes. But we don't want to record this lengthy thing, which means that these lectures have been separated into short chunks of around 10 or 15 minutes. So you can watch in more brief chunks. Now, this semester has no required textbook, which means that all of the information is going to be in the lectures. So if the lectures feel like they're not a good fit, they're not accessible, you're not understanding, please let us know, and we can modify to better fit you.
Hi, I'm Dr. Blumling, and I'll be one of the instructors for BMED 3310 this summer. I've been working at Georgia Tech for a few years now, and I've been spending most of my teaching time dealing with this class, so hopefully I can answer any questions you might have throughout the term. My background is a mix of material science and process engineering and biology, so the general diverse array of things that bioengineers do. I wanted to take a moment to discuss with you PSS and practice quizzes. So, PSS will be happening on Thursdays, and we'll meet via Microsoft Teams, unless for some reason the instructors approve of something else, for whatever the case may be. We'll be forming teams during PSS during the first 2 weeks, and the teams will be required to be in place before Thursday, May 21st. Instructions on the use of Microsoft Teams will happen sometime during the first week of classes. And attendance at PSS does count towards your grade, so it's mandatory essentially. And the TAs will be tracking it, so be there whenever possible. There will be submissions for PSS, and the first week will be individual just because your teams won't have been formed yet. But from then on, it'll be graded as a group, and the intent isn't to make sure you get the exact right numerical answers all the time, and you're not going to be graded on that. Rather, we want to make sure that you are putting in a good faith effort to develop good problem-solving practice and process. So you'll be graded on showing your work and showing your process and making that effort. Practice quizzes will occur most weeks, and like PSS submissions, they're graded based on good faith effort and not whether or not you get the exact correct numerical solution. These things are intended to get you to hone your skills and to practice so that when you take the exams, which are 75% of your grade, and for which the correct answers and process are required, you will already have the experience and have gained the confidence needed to attack those problems effectively.
There will be 3 exams during this course. The first one will cover fluid mechanics, the second will cover mass transfer, and the third will be in place of a final, and it will cover heat transfer. Exams will be open book, open notes, and open Canvas, so anything that's in the course site for Canvas course site is open to you. You will have a few days to work each exam, and you'll submit it as a PDF file. Exams are individual, and students will sign an honor code statement when submitting each exam. They'll be graded on both the process and the correct solutions, and each exam is worth 25% of your grade. So that's 75% of your grade there. The other 25% you can earn through attendance in the PSS sessions, through group submissions of your PSS work, and through submission of your individual practice quizzes, plus an extra point for basically a survey. All assignments have significant flexibility built into them. And since we're planning to post solutions to all of the assignments promptly after the due date for each, then we can't accept late assignments. So both late and missing assignments will automatically receive a score of 0.
So also, remember that the honor code is an important thing to follow. So for example, when you take an exam, when you take a test, you're promising that this is my work and not something I've asked a friend. So understand, the honor code, this is not a warning, we're not trying to scare you, but these are ethics that are important. And engineering situations will show up often. So anytime you you want to come in and ask questions and have a chat or a discussion, the three of us are happy to sit down and chat. Well, have a video call and chat about this with you. So please come to us.
I wanted to take a moment to discuss inclusion and some legal matters. Everyone, students, teaching assistants, and instructors should feel respected and connected as a community of learners in this course. We must work together to create a climate that will enable everyone to realize their full potential. Professional engineering teams composed of individuals with diverse backgrounds, skills, and perspectives are better able to find previously unrecognized opportunities and solve new and compelling problems. Diverse teams only realize these benefits, however, if they operate inclusively, by authentically valuing their teammates' varied skills and perspectives, while working to identify and correct non-inclusive practices and behaviors. This semester is a format environment that is newer to many of us. We're still figuring out what inclusive practices mean in this context of online learning and for this kind of course. It's an open question for us how to do this best, and we'll be working to figure it out together with you. We expect you to join us and give us feedback on what is and isn't working, and when you notice ways to improve inclusivity in the class, both for yourself and for others. Legal matters: if you need teaching or learning accommodations in order to do well in this course, register with the Office of Disability Services. Let us know if you need guidance for that. We will be trying to use universal design for learning principles to make this class as accessible as possible by default, but some services and accommodations require formal enrollment with ODS. And it's a good idea to have for your other classes as well. Also, Family Educational Rights and Privacy Act, FERPA. Students' grades and performance in this class cannot legally be discussed with anyone other than the students. This includes parents. And you can look that up online, and I'll include a URL.